that can help make high-performing workloads possible in the cloud. We'll talk about some of the challenges that we faced and how we bravely overcame them, and some future plans that we still plan to deliver on in the months and releases to come. So as I said, most people here are pretty familiar with OpenStack, I assume. Is there anybody here who has no idea whatsoever what OpenStack is? I didn't think so.
Who would actually raise their hand?
Yeah. So I'm going to go quickly through this. I basically wrote this myself, so you can't. This wasn't copy pasted from a website or something. So it's basically cloud infrastructure, whatever that means to people. It's open source and mostly written in Python. That number's made up, but it's like mostly written in Python. It's kind of organized as multiple projects, each of which has its own kind of like thing it's supposed to manage through an API and potentially like a dashboard. So it pretends to be infrastructure as a service solution. So more about OpenStack Nova itself, which is the compute part, which is probably what the next bullet point is going to say. So yeah, manage compute resources, so basically VMs that consume CPU and memory on your compute infrastructure through a REST API. So it allows you to schedule or schedule VMs across your pool of hardware. Storage and networking is handled by different components, and I won't be talking about them here. And it does, allows you to start, stop, resize, and snapshot your VMs, and also allows administrators to do more advanced tasks like migrate, live migrate. And what's, I guess, maybe interesting, and it gets maybe a little bit forgotten in Red Hat, is that it supports several different virtualization technologies, but we mostly talk about libvirt KVM, which is what most of the features, actually all of the features I'm going to be talking about in this talk rely on. So I guess a little bit of the kind of like what the whole Elastic Cloud idea is about. And this is interesting with this talk because it kind of a little bit is at odds with some of the requirements that are put in front of developers when they want to start caring about high performance and about proper utilization of or specific utilization of resources. So the idea is to allow for quick provisioning and of commodity hardware. And the way it's supposed to do this is it instead of allowing the user to consume resources, it presents them in an abstraction called flavors, which is like a predefined combination of resources you want to use. And it allows only very simple scheduling, which focuses on scale. So you don't, in its simplest deployment scenario, it doesn't try to do anything optimal or smart. It tries to be fast and simple. Like I said, other stuff is handled by different projects, and we won't be going into them, although they might be interesting in the big picture, but this talk is mostly about what Nova lets you do. And I guess an important thing to emphasize, which I already said a couple of times, is that there's no visibility into the hardware their workloads are running on. So user is supposed to be completely oblivious to what is actually the hardware they're running on. This is like a brief slide of the architecture, and like I guess the important thing is that there's an API that accepts requests, and then there's message queues, so most of the stuff is asynchronous. The interesting thing here that I'm going to be talking about a little bit more in detail is the Nova scheduler and how that presented some challenges for us, and this is actually in the next, I guess, 2 slides. But yeah, that's basically it. It's not too important for this talk to go into these details, but the general idea is, like I said, there's an API, and then it's synchronously dispatched to a queue where workers, or actually scheduler, decides where to place the VM, and then it gets done or fails, as the case may be, but mostly gets done, right? So I guess it's interesting if to maybe go a little bit into this and see how this fits with the high performance requirements. There's flavors, as I said, and they carry basic information about the resources that will be assigned to an instance. So it's sometimes, in the simplest case, just the number of CPUs and the amount of RAM that or potentially disk that the VM will have. It can be a bit more complicated than that. And it can be overridden through image metadata, which is user controlled, while the flavors are, which is also an important thing that I guess I forgot to mention, they're admin controlled. So admins would define them, and that's the only thing users would be able to, or the granularity at which the users would be able to consume resources. And yeah, the scheduling is basically, there's no optimal placement. It just has a list of all the hosts, puts them through a set of filters that admin can tune to an extent. And any hosts that pass all the filters are considered. Basically, filters are functions that return true or false for any given host in your pool of compute hosts. And this is most of the filters are written in without going into specific devices or resources, without considering specific devices rather, or resources rather, considering how many of them are there, and just grabbing whatever's there. And that possesses a problem when you want to start thinking about how to actually assign a specific resource, like a specific CPU or PCI device to a VM. So I guess what I try to say here is that the basic infrastructure and the framework that Nova provides does not necessarily play well with trying to do stuff that we try to do in order to give more guarantees to the users about performance of their VMs. So why should people care about high performance? If they want high performance, they should probably use bare metal. That's kind of the what some people think and say. And but as we all know, everything's moving to the cloud, so we have to adapt. But there are some interesting, I guess, use cases, all joking aside. And the famous one, I guess, or the poster child of this kind of stuff is NFV, where telco providers want to move a lot of their I guess, packet processing into VMs, and that can be latency and performance sensitive. So that's kind of where the idea and the push came from. But there's also the fact that there are modern hardware is NUMA capable, which is something you want to maybe start considering even for non-critical applications. And so when we started thinking about this, we realized that we have to find a way to expose or let users request certain high performance characteristics without actually allowing them to choose CPUs or specific devices, because that's not something we really want to do or actually can easily do with the existing APIs and abstractions that Nova and OpenStack provide. And that was I guess the kind of like the design problem we tried to solve when we started doing this. So the next couple of slides are going to be about specific features we added and specific like performance enhancing features and how we expose them through an API and how that works. So I'll try to explain how that's different from just saying I need 3 CPUs and hopefully, or X amount of RAM, and hopefully that will be clear, because that's kind of the crux of this talk. So the first thing is obviously we wanted to make Nova aware of the NUMA characteristics of the compute hosts, because this can help with memory access latency. I'm not going to go into a lot of details here, but yeah, basically, if you're accessing memory that's not on the NUMA node the code is running on, there's a penalty to accessing it, or it takes longer to access that memory, which is obviously something we want to avoid as much as possible. For performance-sensitive workloads, we don't necessarily care about this, or maybe we don't need to care about this for cheaper VMs, but it's important for high-performance workloads. And this is also interesting in combination with dedicated I/O devices. Yeah, so this is for first time I gave this talk was at KVM Forum, so there was a little bit of libvirt KVM stuff here, but libvirt will expose host capabilities. NUMA topology of the host. So first thing was to somehow take that and store this into Nova and start making placement decisions based on this. And so this is basically how we decided to expose this to the user. So we would only allow users to actually admins to say that a VM can have a certain number of NUMA nodes. If you just say 1, that's also a valid thing, but it still means that Nova will make sure that that VM is contained to a single NUMA node. And then there's some additional options that I guess has limited usefulness, but it's there. And so I guess the interesting thing here, or something I would like to emphasize, is that there's no way for users to choose which NUMA nodes this goes to, or something like that. It just says, I want this to end up confined to a NUMA node. Yeah. So how is this done in Nova? As we've said, there's a way for compute hosts to expose this information to the Nova scheduler. Requested topology is saved as well, and then once the instance is being scheduled and placed on a host, we would basically see if it, based on the number of CPUs and the number of CPUs available on the NUMA node, see if it can fit there, and if not, move on. So as you can see, this is different than placing VMs on hosts. We're basically placing them on NUMA nodes, and the fitting algorithm would place it on any available NUMA node on the host. So there's no way to request a specific NUMA node, which is kind of different when you also want I/O devices as well, like PCI devices, but we'll get to that. And then finally, since libvirt driver is the backend for Nova, is the only one that implements this, libvirt does the work of actually confining this, and this is done by the vCPU pin element here. That's when you define the domain in libvirt. And as you can see, we basically confine a set of CPUs to a set of host CPUs. So as you can see here, we don't place them on single CPUs. We place them on the set of CPUs. So in this case, 0 and 1 would be the first NUMA node, I guess, of the host. This is also important for memory as well, not only CPUs. So this is basically telling libvirt to assign memory from a specific node. So next thing we did is huge pages awareness. Oops. Yeah, this is also interesting because of performance. I guess the win here is that there is no if you don't have a lot of pages to keep track of, then you can cache all the virtual to physical addresses in a constrained resource called the TLB, and if you can, so it makes I guess you use the TLB better, and that makes it perform better. And the idea, I don't know, these slides were done by a colleague of mine who actually did the work here, and there's as much as 15% improvements, and there's also a reference there. So I guess, sorry, that's the idea there. So this is an example of how much more efficient it is if you have larger page size. So you basically need only one entry in the cache, and you don't have to actually do all the walking of tables. You just have a cache hit, and you have your actual physical address. And that's obviously way more efficient and important for workloads that care about that kind of stuff. Different architectures have different page sizes, but that's not necessarily important here, other than knowing that we had to somehow expose this through the API in a smart way, because you don't want to make assumptions on what kind of hardware you're running on. So the API bits of this was setting, allowing the flavor to just say, use large pages. What that means is, as we said, depending on the actual hardware. And then we added some kind of any, which allowed us to actually let users request it if the admin allows something like that, which I think is also slightly limited in its usefulness, but it's there. I think what's interesting to mention here, and I probably forgot to mention it earlier, is that this kind of brings in the fact that, I think it's maybe mentioned later, you have to set this on the host when you boot it. So it kind of breaks the promise that you can quickly provision any type of hardware. There's now additional work that needs to be done there by the sysadmins or operators of the system, but there has to be some kind of a trade-off, and we don't live in the perfect world, so this was deemed acceptable by people, but it's worth mentioning as this was one of the constraints of the design. And yeah, so huge pages are implemented on top of the NUMA awareness, so they are per NUMA node. And there's even we allow asymmetric allocation, which is apparently a feature people wanted. So yeah, so this version of libvirt and above exposes huge pages, or exposes the information about pages available in the host. So same as before, we can grab this from all the compute hosts and consider this when placing VMs. And yeah, so this is the how this is implemented. Once we place the VM, this is how we request this from libvirt. Nova libvirt driver generates this XML and passes it over to libvirt. So CPU pinning is actually maybe not the best name for this, because it's actually giving VMs dedicated CPUs. So as we said, normally you would let your VM use any available CPU, and this will be in the KVM case and libvirt case up to the OS scheduler to decide. But for obviously performance sensitive apps, you want to allow a VM to completely use a CPU. So that's one thing. And then there's hyper-threading comes into play here as well, which presented interesting problems. Because sometimes you wanna prefer being on the same basically physical core because of better cache utilization. Sometimes you don't, and that's something also that's very tricky to properly model in the world of resources that Nova knows about. So the problem, and where this abstraction breaks a little bit, like with large pages, you want to have a separate set of hosts where you place these VMs, because mixing workloads that don't care about performance and the ones that do is just something that we decided is a little bit tricky, or an unnecessary complexity that we don't want to handle in the code. So we pass this off a little bit to the system operators and tell them, if you want to provide this feature, you need to use a feature of Nova that allows you to separate your hosts into what's called aggregates. So if you want to use this, you need to use this in combination with saying VMs that go on these hosts are only performance VMs, and they will only be pinned to specific CPUs. And there's obviously no overcommit in this case, because this kind of defeats the purpose of dedicated resources. And yeah, so kind of like the idea, maybe a subtlety here, is that it trades off the maximizing hardware utilization to having high performance VMs, which is kind of like the more expensive VMs that people want. Yeah, so we had, again, a simple API that says we want a shared or dedicated CPUs. Shared is the default. This is what Nova would do normally. Dedicated would have to be combined with request that says go to that specific set of hosts. And then in that case, Nova would keep track of which CPUs are dedicated to which VMs and allow you to make these, guarantee you that the placement will be dedicated. Very similar to the other parts of it, the other features we implemented. This stuff is exposed, tracked by Nova. Placement decisions are made. The placement algorithm currently is not super smart. It basically finds the first best fit, I think. It tries to be a little bit smart, so it will try to utilize the CPUs of different NUMA nodes equally, but it doesn't do it in any kind of like globally optimal way. It's just in the way how we sort the available CPUs when we try to place VMs. And so far, we haven't seen any problems or complaints from users with this, so far it seems to work. Yeah, I don't know. That's basically, so far it works. In theory, it's not very optimal because it goes through the all permutations of possible NUMA nodes, which is, if you have a lot of NUMA nodes, it starts to get slow, I guess, but we're not there yet, so we'll fix it when we get there, maybe. Yeah. That's it. So this is the same as confining to a NUMA node, except you confine to a single CPU, basically giving the VM dedicated CPUs, and Nova tracking makes sure that you never share a CPU on that particular dedicated host. So a third set of like an additional feature we added is also if you request NUMA aware instance and you request a PCI pass-through device, it kind of doesn't really work for you unless the device does I/O on that same NUMA node. And this was added as well. The work was not done by Red Hat, but it's a good example of how a couple of companies collaborated on these kind of requirements. And yeah, that's basically it. And the problem here is that you can't, the takeaway here, or the bug that we have, is that you can't match devices to NUMA nodes. So if you request a 2 NUMA node VM and you have 2 PCI devices, they may end up on the same NUMA node. Which may not be what you want. You want them to be on separate NUMA nodes, but there's no way to expose this. Yeah, so this is what were the good parts. The good parts were that, at least in theory, but from what we hear from customers, this enabled OpenStack to be used by a set of users that would not necessarily have a lot of use for it, and they all got involved with this in planning, some of them in development, and it was just generally a good thing for the community as I so eloquently put it in the second bullet point. But there were some problems with this. There's, as we've seen with some of the examples with large pages and CPU pinning, it does complicate your operations because now you have to know which hosts are which, and kind of breaks the promise that you just throw hardware and scale out infinitely. And yeah, it's, as we've seen, tricky to expose these details in a reasonable way, like, for example, with the NUMA nodes and PCI devices. And there are some specific challenges with the way this was implemented and done, because it's not used by a big chunk of users, so it's off by default, which means it doesn't get all the testing we would like it to get. We're getting better at it, but it's just the reality of life. And once we started doing this, a lot of the internals were not up to the, were just not designed to ever handle these kind of requests, as I tried to describe in the beginning. And this is where a lot of the development time was spent. And but in the end, we all learned a lot, or something. That's great. So I kind of put this in future plans, but it's really a bug that live migration won't work properly, so we should probably fix this.
Is it how a feature? You could probably take advantage of this track and use host pass-through, for example.
Yeah, it's a bug for just purely VMs that don't do any pass-through. So we should definitely support this properly. Currently, we don't do it properly. Sometimes it might work, sometimes it might not. So, and yeah, there's some features. The threading features were actually merged not long ago. It's not released yet, but it's merged, and this was also done by engineers from different companies, so that built up on a lot of the work that Red Hat folks did. So this was definitely a good example of how this model worked well. And device pass-through, as I've spoken already. So with that, I will allow you to ask questions. There's 3 scarves here that I'm supposed to give to the best 3 questions. But yeah, so give me at least 3 questions. Okay.
2 questions.
You can.
First of all, for a couple of years now, there has been SRIOV around. Is there any support on the roadmap?
Yeah, so there is support for SRIOV. That's what I mean by PCI devices support. The reason why I didn't.
Basically, pass-through means SRIOV for you guys.
Yes, in the general case. It doesn't have to be. You can pass through, for example, non-SRIOV devices, but yeah, it's majority of users would probably use it with.
The other question was on the hypervisor machines to turn on kernels at same space merging as well?
No. There was a good reason, but I forgot. Yes, I should have looked it up. This work was done like a year ago now, so yeah, I kind of forgot about those details. Sorry about that. But thank you for asking. Come for your scarf if you want.
Is the scheduler aware of the difference between the CPU and, for example, the memory? There could be a host with a faster memory, low latency. This would be a host that's higher performing.
No, in theory it could be, but it's not. So as long as libvirt basically exposes this kind of information, which I think it does.
The latency of the memory?
I don't know. But yeah, as long as libvirt can tell us about this in Nova land, we could probably do it, but we don't. Scarf. Actually, maybe there will be more questions, so let's see who gets the scarf now. Well, so it is. You can do this. I mean, as long as, like, Nova would allow you to say that these devices are fair game. It's just not something we necessarily focused on, and not something that the community focuses on, because a lot of the community members that work on this are also from the networking world. So it's not tested, for example. Or not heavily tested. But yeah, it's something that we in theory support. GPUs. Yeah. And
Can you repeat it?
So the question was, does Nova allow for evacuation of these VMs? And that is a good question, because when you say evacuation, Nova uses this word very liberally, so it can mean a number of things. But in the simplest case, it means that you know a node is down, because you shut it down because something was wrong with it, and you want to start these VMs somewhere else. There's two ways to do this: to tell Nova where to put it, and to let the scheduler decide again. If you let the scheduler decide, it will work. If you tell it where to go, then it's not really tested. It should work, but I wouldn't, if you're a customer, I wouldn't tell you, yeah, 100% use this. We would have to test this, I think. Yeah. But as long as you let Nova decide, it will make the same decision that it did when placing the VM. So, yeah. Okay, thanks a lot. If there are no more questions, 3 people who ask questions and want scarves can come and get them here, because all questions were amazing. And yeah, logos.
Before you leave, can you upload the presentation? Or you have it on GitHub, or?
I think I have some. I guess I can.
Okay. Just a moment. We have to get some stuff, and then if you have any question, I mean, I can fetch it out.
Can I? Yes. Can I actually? Can you send me an email like next week, and I will send you the presentation, because I completely forgot how to.
All right. So.
And I don't want to Google it now. So
we will contact you. I will contact you.
Send me an email to like my Red Hat email. And,
okay. This is just because the presentation will be available online. So
yeah. I will definitely send you the PDF version of it.
Okay. Well, thank you.
And you get a sticker or a speaker?
Wow. Yeah. So I think
And a hoodie.
And
right?
scarves.
Nobody likes scarves.
No, they're not nice.
Have you had trouble giving them all away?
I think that's because it's not cold.
It's not that cold. True.
Yeah.
Well, it's not fun.
If there were like minus 10 centigrade, it would be more popular, I guess. Last year it was snowing.
Yeah, but probably people will have had that anyway before.
Did you already get the sticker?
Oh, okay. And the presentation as well? Presentation as well?
He will send the presentation, he doesn't have it in PDF.
Ah, okay.
It's not so.
But we can get even the HTML in
Was
case.
probably
But,
is it
yeah.
implemented in raw? So it's not.
Thanks, dude.
Yeah, I saw it.
See if that works.
Fraction of that. I was just curious.
Yes, that'll do.
So we did. So well, the way it
It's
worked.
advertising itself as a widescreen display, but it isn't actually a widescreen display. So.
I don't understand how
Well, I'm glad I came in early this morning because I noticed that it looked really crappy, and I started to think about how to.
I think it shouldn't really work, but to be honest,
I mean, they cost a fortune, right? And even the bulbs cost. I think the bulbs are several hundred euros.
My attention system when you mentioned that basically when you are positive virtualized VM running on NUMA node, basically user have no chance to specify the company host.
I'm going to leave that up for human interest.
no. Yeah,
I'm going to take a picture of the room at the start of the presentation, and I'm going to try and incorporate it into a demo.
Okay.
So
But if you like the schedule aside,
I will explain this again in the talk, but it's basically, it's difficult to demo what I'm talking about in a way that looks interesting at all, because it's just waiting.
Yeah. Right.
So you see people like Steph do cockpit demos, and they look so cool.
Yeah.
And
they
then
do
I'm like,
things.
hey, could you do a demo? I'm like, I could, but you just, do you go get a cup of coffee? That's all there is. So.